Hi everyone, today we're going to be going over the LunchLine data structure, also known as a linked list. So first, what is a LunchLine? A LunchLine is a data structure, a complex type that can hold many pieces of data that is defined recursively or in terms of itself. So working with our definition of a LunchLine contains the name of the first member within it, that is, string first, and then a reference or a pointer, for example, to another LunchLine that contains subsequent members, which is LunchLine rest. So let's go over the basic structure of a LunchLine. Don't worry if this looks intimidating, as it will be explained shortly. As detailed before, a LunchLine has two member instance variables, string first and LunchLine rest. If we think of a LunchLine as one of these boxes, like this one here, then each LunchLine contains the name of its first member, for example in the first one foo, and then a pointer or an arrow to the next box in the sequence, which contains more and more LunchLines, like this one here. Let's look at the constructor for a LunchLine and examine how that is declared. We provide the constructor defined as public LunchLine, a string leader, and a LunchLine all else, which represent, of course, the first element in our new LunchLine and the remaining elements respectively. Note that if we want a LunchLine to end somewhere, we can pass all else as null, and then there won't be an arrow to more LunchLines afterwards, like you can see here. So as you can see, we nest several of these constructors, so new LunchLine of foo, and then all which has leader as foo, all else as this thing here, new LunchLine bar, and then within this constructor, leader becomes bar, and all else becomes this new LunchLine here. And then we have another leader here, baz, and then all else is null. And what this does is then there won't be any pointer to it, and therefore the LunchLine ends at baz. Briefly, I'm just going to show you the LunchLine API, or the list of instance variables and methods within the LunchLine class. I'm going to go over each of the following methods shortly. The first method I'm going to show you is the printLineMembers method. In this method, we want to go through each of the members of the LunchLine and print the names of their first variable to the screen. LunchLine is a recursively defined class, so therefore each of our methods are going to be recursive. Our recursive base case, or when operation ends, is if there's nothing left in the LunchLine to look at. So for example, in this LunchLine drawn here, that's going to be within the last member named baz, like this one here, since there is no pointer to any succeeding LunchLines. So if we hit such a LunchLine, then we print the name of the first member, so baz, to the screen, and then return to make sure execution doesn't continue. Otherwise, we print the name of the first method in the LunchLine we're looking at, and then add a comma, and then we move on and call printLineMembers on the succeeding LunchLine. So I'm going to first quickly walk you through how printLineMembers works on this drawn LunchLine here, and hopefully the next couple of recursive methods are going to be easier for you to understand. So we first call printLineMembers on this LunchLine called foo. We check if the rest is null, which is not true because there is a pointer here to another LunchLine. So we ignore this if condition and move on to this system.out.print. Notice that it's not printLine because we want to add a comma but not a new line. So we do system.out.print of this dot first, which is going to be foo, and then we add a comma here. So first foo gets printed to the screen. Then we call printLineMembers on rest, which is this LunchLine, this big one here, right? And then we again check if this.rest equals null. Keep in mind that this is now this big LunchLine here. This.rest is not null since there is another LunchLine there. So we go ahead and ignore this if condition here again. Then we go and print the name of the first member to the screen, so bar, and then add a comma again. So you get bar and then comma. And then we call printLineMembers on the next LunchLine, which is this one, which is called baz. Now we check if this.rest equals null, And if so, which is true, because there's no reference to another lunch line here, we're going to go ahead and print out the name of this stuff first and add a new line. That's why we have print line and not just print. And therefore we just print out baz, and then we're done with printing. So now we return to make sure execution stops and this doesn't execute. So once we return, this rest of print line members is done for this lunch line here. Then because we're done, we go back to the previous one here. Again, it's done. So we're done executing and we get this nice result printed. The next method is called countLineLength, which might be a bit easier to understand than printLine members. Again, our recursive base case is if this.rest is null. That is, if there's nothing left to look at in our lunch line. So for example, again on this node, because rest is null. And if so, we return 1 because there's nothing left, and so the size of our lunch line is just 1, which is just the lunch line we're looking at. Otherwise, there's still stuff left to count. So for example, if we're looking at this beginning node, foo, there's still stuff left to count, so return 1 for the size of this lunch line, plus the length of the remaining parts of the lunch line, which is represented by calling this.rest.count line length, as below. So let's now look at the add to front method. We want to add a new lunch line with name addme to the list. Let's pretend addme is called foo, and we can draw this here. So foo, and we want rest, or the circle here, to point at the existing lunch line like this. And we want to create this arrow here. And so doing this is actually fairly simple. We just create a new lunch line with the front of it, the name of the first element as addme or foo, and the rest of it is simply the existing lunch line, or this. And then we just return this newly created lunch line. The next method we're going to look at is remove front, which is actually a fairly simple method. We want to remove the front node, for example foo, so we want to get rid of this, and then return a lunch line containing the rest of the elements in our current lunch line, so this thing here. Luckily for us, within our current lunch line, there's an easy way to access a lunch line containing these elements. We just use the rest instance variable. So we pretty much just have to return this.rest, and then we're done. Now let's go over to the add to back method, where we want to tack on another element to the end of our lunch line. That means we have to run through the length of the lunch line, which we do recursively. If we reach the end, that is, when rest is null, we link our new element to the end of our lunch line by saying that this.rest, which is currently this null pointer here, is going to be equal to this new lunch line with the name string addme, or quux in this example. Otherwise, we're going to recursively call add to back on the next element in the lunch line until we get to such a state where we can add the new element. Our second to last method is the cut in line method, where we want to add a new element somewhere in the middle of our lunch line. As before, we're going to check for a condition where it is favorable to add this new lunch line, which is when the next element has first equal to ahead of. If so, then we can't simply replace this next element, since we have to add addme while keeping a reference to ahead of. In other words, let's say that this is the new element that we want to add, and we can't simply redirect rest to this new element before redirecting the new element's rest to the existing part of the lunch line. So what we do is we have to temporarily maintain another reference called next to that existing element. So we call this next. And then what we do is we redirect the existing reference to fit that. So we first link the new element's rest to our next pointer. So now we're eventually pointing here. And then afterwards, we redirect the rest pointer of the lunch line we're looking at to our new element. And as before, If that's not true and we don't see a head of here, then we simply call cut in line on the next element in sequence. The final method we're going to look at is the most complex, as we have to merge two lunch lines in our alternating fashion in the merge lines method. This can be done without too much difficulty, however. We first check if the lunch line we're examining terminates, so checking if the rest of it is null, and if so, we can simply slap on the remaining bits of the other lunch line we're examining. In the reverse case, similarly, we check if the rest of the other lunch line we're examining is null, that is, if it terminates, and then if so, we can simply slap on the bits of this lunch line that we're looking at. If both lunch lines haven't ended yet, however, then we have a bit more work to do. In that case, we're going to merge two individual pieces at a time and then recursively move on to the rest of the lunch line. The first part of our new merge lunch line is the first element of our own lunch line, so this stuff first. The rest of it will be a new lunch line with first element others first, which is the crucial merge step, and then the rest of that will be simply the result of recursively merging the remaining parts of both lunch lines. And that's the end of our lunch line video. Note that if you need help with the code, you can just go check out our sample code repository on GitHub, which is available at the link on the screen and in the video description. And as always, I hope you learned something.